Imagine a star that could repeatedly and predictably explode again and again. Sounds like the stuff of science fiction, but what if I told you it's real? What if I told you that in just a few months, we're gonna have a star going over, it's gonna be visible from Earth. So the star is called T Coronae Borealis, or just T Cor Bor, or sometimes referred to as the Blaze star. This is what's called a recurring nova. So this is a star that can repeatedly explode into a nova over and over and over again. T Cor Bor is usually just a magnitude 10 binary star. Nothing special about that, it's very, very faint. But one evening in 1866, it suddenly brightened up significantly to just a magnitude 3 star. Remember, the magnitude scale is upside down, so the lower the number, the brighter it is. It's an astronomy thing, don't ask. But this is a lot brighter. It's still not as bright as some of the brightest stars in the night sky. Remember, like the magnitude scale is indexed after Vega, which is index 0. So that's one of the brightest stars. And then the higher the number, the fainter they are. So it's definitely not going to be one of the brightest stars, but it's significantly brighter than a magnitude 10. Stars brightening up like this for short periods of time is called a nova. This is not uncommon. These have been recorded throughout history numerous times. What is special about this star is it did it again in 1946, exactly 80 years later. So the question now is, how can a star explode multiple times? I mean, surely when a star goes nova, it gets destroyed, but it doesn't. See, it's important to note that it goes nova, it doesn't go supernova. Supernova, everything is gone, it's destroyed, and you just have whatever's left in the center, neutron star or whatever. This one doesn't. So how does this work? You have a binary system of 2 stars. One of the stars have already shed its outer layers and is now a white dwarf. This white dwarf will have a companion star orbiting close to it, and in this case, it's a red giant. The white dwarf, the smaller of the stars, is siphoning materials off the upper layers of the red giant, slowly increasing its mass. Now, if you watch my videos about how to build a supernova, you will think, but Astro, that sounds an awful lot like a Type 1a supernova. And you're right, it does. This is the exact same setup as we have for Type 1a supernova. So why doesn't T Cor Bor go supernova? To understand that, we need to talk about the Chandra-Sekhar limit. Now, what is this? This is a limit for how heavy a star needs to be before it can go supernova. That limit is about 1.4 times the mass of our sun. If a star is smaller than that, if the white dwarf in this binary system is smaller, is lighter than that, then it's not heavy enough for that total core collapse and to explode into a supernova. Instead, what happens is the mass accumulates slowly onto the surface, and as the mass increases, we just get smaller surface explosions that just rips the outer layers of the star away, leaving the center of the star intact for it to continue its fusion process and to continue to siphon materials off the star for it to explode again. So surface explosions rip the outer layers away, the star brights up, becomes very bright for a short period of time, and then it fades again, and then it spends time collecting materials until it's ready for its next explosion. So the question everybody's of course going to ask is, when is this thing going to explode? And it's soon, very soon actually. But the boring answer is we don't really know exactly, because we only have two measurements. We have one interval that we measured, so we don't really have a lot of data to make an accurate prediction. But we can make some qualified guesses. So I sat down and I calculated the days between the last 2 explosions, and there were 29,127 days between those 2 explosions. So if we take the last explosion in 1946 and we add 29,127 days, we end up with November 8th this year. So November 8th, 2025 is the predicted day if they're going to explode at the same time. It's the same interval between them, I should say. However, there are indications that it might happen sooner. The last time the thing went nova, we saw a dip in the light just before it exploded, and And we have seen that dip again. So if that dip is the time period from when the dip to when it explodes, it could be as soon as in the beginning of February, which is basically now. So it's really, really difficult. Again, I'm recording this here at the end of January, and obviously it hasn't exploded yet, but there's a good chance by the time I've recorded, edited, and published this video, it might actually have exploded. Point being, it should be very, very soon. Keep an eye on it, because again, it's going to be 80 years before this happens again. So if you want to have a chance to get a glimpse of it, well, you should get your telescope ready, because in anywhere between now and November is a good chance we're going to get a new star in the night sky. Most stars consist of a fusion burning core and a more passive envelope. These stars were then classified based on the strength of the Balmer series absorption lines. Now, if you don't know what the Balmer series is,